Well, welcome. I'm going to go a little bit more deeper into acid-base problems this time, and what we have to do is we have to think about what controls the acid-base status of your blood, of your plasma. Two major things we have: bicarbonate ion concentrations, because we know the bicarbonate ions will buffer the acid in our blood, and secondly, CO2 levels. Okay, we know that if we have more CO2, that will get converted eventually into hydrogen ions, which will produce acidity. And so because carbon dioxide and bicarbonate ions are the major players in acid balance, we can look at the dissociation of those two, because we have the basic CO2 plus H2O, carbonic acid, which then can dissociate into hydrogen ions plus bicarbonate ions. And from that, and looking at the dissociation constants and so on, we get what's called the Henderson-Hasselbach equation, which is the pH is equal to pKa plus the log of the concentration of bicarbonate ions over the solubility of CO2 in your plasma times the partial pressure of the CO2 in your plasma. So we can look at this formula and see the pKa, dissociation constant of this reaction, is always set as long as temperature and so on stay the same, which is what we expect, and this value is equal to 6.1. Therefore, the only thing in this equation that really changes within our body are these two: bicarbonate ion concentration and the partial pressure of CO2. Its solubility again will remain the same in the body under normal circumstances. So therefore, what we're going to do here is just look at the way that these two relate with each other and how they affect the pH of the body. Now firstly, let's just plug in their normal values. And so for normal values, we've got pH equals 6 plus 1 times the log of bicarbonate ion concentration, which is 24 millimolar, over solubility constant of CO2, which is 0.03, multiplied by 40. And if we do, the log of this value, is approximately equal to 1.3, which gives us our normal pH of 7.4. So that gives us our normal pH, so we know that's fine. Now, let's have a look at this equation, however, and let's see what happens, say, for example, if we increase bicarbonate ion concentration. If we increase bicarbonate ion concentration, what you can see happen is this value will increase, the numerator, and if the numerator increases, the log of this value will become greater, so it'll be higher than 1.3, so this value will get bigger, and therefore the pH will become greater as well too, so it'll become alkalotic. So therefore, an increase in the bicarbonate ion levels is going to lead to an alkalotic situation. Cool. Conversely, if we decrease bicarbonate ion levels, this value becomes less. The log value of this becomes less, so it becomes less than 1.3. Therefore, the pH will decrease, become less than 7.4, and eventually drop low enough that we could then say we then have an acidotic situation. So therefore, a decrease in bicarbonate ions is going to produce, or is going to lead to, a pH that is less in value, and therefore showing that we're going to have an acidic situation. Conversely, if we look at the partial pressure of carbon dioxide, being that that's the denominator, an increase in PCO2 is going to increase this value, so it means the fraction value is going to be less. If this value is going to be less, then the log of that value is going to be decreased as well too. So again, the pH will be decreased, so therefore an increase in PCO2, increasing the value of the denominator, is going to make this value less, therefore the pH will be less, and therefore that will be an acidotic situation. So of course, elevating PCO2, so increased PCO2 levels, is equivalent to acidosis. And on the other side, a decrease in PCO2, of course, if this value is less, the value of the whole log value is going to be increased. If this value is greater, we add it to 6.1, we get a value much greater than 7.4. So a decrease in PCO2 leads to an alkalotic situation. So hopefully by looking at the Henderson-Hasselbach equation, it's not too scary really, is it? It's quite simple. Use this in your understanding. If you can understand this, acid-base is oh so easy. And so get some really good fresh marks there.